I'm going to show you another direct truth table check for validity. Went with some green this time, maybe a little harder to see, but I think we need a little change here. Main reason I'm doing this is to show you how to keep in mind efficiencies. Figure you can, or hope you can, go from a 4-row to an 8-row, or 4 cases to 8 cases. In any case, let's do this problem and talk about the efficiencies. All right, so first premise. Right here is not P if and only if. It's important to talk these out in terms of what the symbols mean as well. Very helpful. Not P if and only if either Q or R. That's so we make a column there. We'll label it P1 for premise 1. And secondly, we have 3 premises this time. If not R, then both Q and not P. We'll label that premise 2. And not R. That's our third premise. And finally, P or R is our conclusion. Okay, the efficiencies, premise 1 and premise 2 are very complicated. Premise 3 is simpler. We can do it quicker and easier, and from there we'll be able to eliminate many of the rows or cases, half of them in this particular case. All right, so R goes true, false, true, false, true, false, true, false. Okay, so not R would be the opposite of that. False, true, false, true, false, true, and so on. Make that true a little better. Okay, now remember, we're trying to see if there are any cases where all the premises are true and the conclusion is false. And in all of the odd-numbered rows, in particular row 1, we can't have that. We can't have true, 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 false, because we don't have the third part of what I just said. So we can just kind of scratch out all those positions and not calculate there, or you could keep it in mind perhaps as well. I want to visually show it here. All right, once again, I've scratched out the rows where I don't need to calculate because there's no way I'm going to be able to show invalidity there. All right, next, second simplest is P or R. Incidentally, another reason that we might want to go here is we have an or claim. We're looking for the conclusion being false. We're looking for a different thing for the conclusion as opposed to the premises. And an or claim is only false when both parts are false. So more often, more often than not, pending some odd structure, this claim is typically going to be true. And so we're going to be able to eliminate extra here as well. P or R with P being true is true. That's off the table now. We got a true conclusion. We're looking for all true premises and a false conclusion. This one's also true. Case 4, we have P true and R false. Okay, P being true makes it true. So we're only down to 2 possibilities here. And as a matter of fact, though, in both of these cases, the conclusion is false. But we still have some work to do. We could wind up in case 6 or 8 with all true premises and a false conclusion. In fact, we will. Let's see. All right, so at this point, it's really a toss-up between these 2 claims. Although I'm actually going to prefer premise 2, being an if-then. We can quickly and easily tell that the claim is true whenever the antecedent, not R, is false. In this case, though, not R is true because R is false. So we have T on the left. On the right, Q and not P. That's going to be true. We have Q and not P indeed. That's true. In the last case, not R is also true. Q is false, so that's going to make the expression in parentheses false. We'll end up with T horseshoe F in this case. So our second premise in case 8 is false, and we can stop calculating there. All right, just one calculation left to do. We got to do it, not P. Expression on the left of the if and only if is true. Q or R is true in virtue of Q being true. Whole claim, therefore, is true. And indeed, we have now found our one case or row where all the premises are true and the conclusion false. Not that we had to. We could have had more than one row, as in the problem above, or none, as is the case in a valid argument, but this one we've just shown is invalid. We can go ahead and write it out, and we say let. We have three truth value assignments here. In case 6, we have P as false, P be false. Q is false, true, but Q be true, and R be false. Reading off again from case 6. And there we go.